All right, so yesterday we talked about the law of sines, and specifically we went down this path right here where we talked about angle side angle or angle angle side, and this is where we used the law of sines and we had one solution. Today we're going to look at the ambiguous case, which is side side angle, meaning we're given two sides at an angle in that order, where we're still going to use the law of sines, but there is going to be a couple or three different types of solutions we're going to have to account for. So in your notes, just we're going to put a little blurb here just on the SSA case, and let's just label this the SSA ambiguous case, and we're going to start to write out the different possibilities that we could have here. So the first one we'll talk about is a no solution case. So in your notes, you're going to kind of write out these different possibilities. One of the possibilities, and we're going to assume that we have some triangle here that is some angle here that is acute. So you're just going to draw out kind of the same triangle each time, or the same setup, where we're just going to assume that we have the angle that's given here is angle A. That's going to be the angle that we know. And then we're going to label this side B. And side A is going to be, this side right here. Now this side A, is going to be the side that determines how many solutions we have. So one thing that I want you to write in there right away is oftentimes we're going to think about what is the height of the triangle in this case. So I'm actually going to put in blue here, if I were to write in the height of the triangle given angle A and side B, I'm just going to label this because we're going to refer to this kind of often. The height is always going to equal B times the sine of A. So we're going to write in that. So here's the height of the triangle. Now, if the other side length that's given to us, so if side A right here is simply less than the height, right? If it's like this much, or it's not long enough to even get past or get to the other side of the triangle, that's when we're going to have no solution. So imagine we have a side A. So I'm going to label this side A. So take some time to write this, part in your notes. And it might take a little bit of time to write out kind of that diagram. But the key here is that you have this setup right here. You have angle A, and for all these cases, we're going to write it kind of in the same way. We have angle A, we have a side B that's connected to it, and then we have another side that is given that we don't know the length of. This would be a no solution because in this case, if the A value, so I'm going to put down here, I'm going to put A is less than H in this situation, that means that we're going to have no solution. So this is no solution there. And I'm going to kind of box this in. Whenever we have this side length that simply doesn't reach or it is too small to even make a triangle, we're going to have no solution. Okay, so in your notes, I want you to just kind of set aside maybe a big chunk of space where we can write these different cases here. And I'm going to show you a no solution type of example right now. So let's go to this one right here. This would be an example of a no solution right here. And you don't have to So in your notes, you don't have to draw out this picture. This picture is just going to be here to kind of show the same idea. So the only thing you need to write down is this information right here. There's the information that's given. We have a triangle ABC, and we have angle A is 54, side A is 6, and side B is 8. So again, you can see the picture. You can kind of see the picture over here where we have 54 degrees, we have the side 8, and 6 is going to be too small to actually make a triangle. Now, if we were to calculate the heights of this triangle before we even attempted to do this problem, we could know that it's no solution. I'm going to show you a couple different ways to do this problem. So one way is to say, well, let me calculate the height of this problem. The height of this triangle is going to be B times the sine of A, which in this case is 8 times the sine of 54 degrees. So if I type that in, 8 sine 54, you can see that my height is about 6.47. So if I wrote that down, I know that my height is 6.47, and therefore my A value here is 6, and that's not even, it's less than 6.47, right? So I have this A value 6, or in other words, this side length that you can kind of think of as like on a hinge, you can kind of move that around. It's less than the height. 6 is less than 6.47, so therefore you would know in advance that this is going to be no solution. Now, another way you can do this problem is if you just went ahead and tried to solve the triangle by using the law of sines, you would run into an error when you tried to calculate the next side. So for example, let's say we didn't have this nice picture that was already kind of written for us, and let's say we just wrote out, our triangle like this. We said A, B, C, and we said this is 54, 8, and 6. And if we tried to do the law of sines here, what we would do is we would say, all right, the sine of 54 divided by 6 is equal to, now the only place we could use the law of sines here is if we solved for angle B. If you look at this picture, the only thing we would even have a chance of solving for is this angle B, because we know the other side length right there from law of sines. So then we would say the sine of B over 8. So let's say we go ahead and try to use the law of sines. We write out the equation, and what we would get here is we would have to multiply by 8 on both sides. So we would get 8 times the sine of 54 over 6 equals the sine of B. Now, if I'm going to solve for B right here, if I'm going to get B by itself, I'm going to take an inverse sine. I'm going to take sine inverse on both sides. So B would equal, if I solve for B, the inverse sine of whatever I have right here. So let's say I'm going through the problem and I have, this is my answer for angle B. I take sine inverse of all of that, which is just some number. Then let's see what happens there. So if I go ahead and calculate this out, 8 times sine 54 over 6. So 8 times sine 54 I already have in my calculator, and then I divide that by 6. Okay, so that's what it is. It's 1.07 something. this is going to give us a no solution, because now if I take the inverse sine, so second and then sine of that answer, 1.07, now you can think back to previous chapters here. If you think about the unit circle, even though we're not using the unit circle, if I said where on the unit circle are the y values 1.07, you'd say that's not possible, right? Because the y values on the circle the maximum is 1. So we can't have any y values that are above 1. So therefore, when I do this in the calculator, it would make sense that when I do this, I get an error. And it says domain error. Quit, go to, whatever. And so this is a clear case where when you're trying to solve this problem, there is no solution, right? B just doesn't exist. It's not possible. Okay, and it kind of makes sense in how we're doing this problem. So there's really two ways you can go about this no solution. Okay, I guess the easiest way is just to calculate and do this little analysis here and figure out what the height is, and if the a value is less than the height, it's automatically no solution. But even if you forget that and you go ahead and just try to use the law of sines here, you're going to run into a roadblock anyways. And when you try to solve for that angle B, it's going to say error. It's going to say no solution. And then that would give you feedback to say, this must be no solution, right? And so you should have indicators there trying to remind you that this triangle is just not possible.